Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is graphing system of linear inequalities. Solving a system of linear inequalities is very similar to solving system of linear equations. But with inequalities, we are not finding a point of intersect. Instead, the solution set will be the region that satisfies all of the linear inequalities. The best way to solve a system of linear inequalities is to use the graphical method. Okay, when solving the system of linear inequalities graphically, I'll explain you the steps that we are going to follow. Step 1. Solve the inequality for y. That means whatever inequality you get, just set that inequality sign into equal to sign and rewrite all the equation in terms of y. You have to isolate y on one side of the equation and shift all the other terms to the other side of the equation. And step 2. Treat the inequality as a linear equation and graph the line as either a solid line or a dashed line. It depends on the inequality sign. In case if it is a greater than equal to or less than equal to sign, you have to draw solid line in the graph. In case if there is no equality sign, I mean only greater than or less than symbols are used, you have to use dashed line or broken line. If the inequality sign does not contain an equal sign greater than or less than, then draw the line as a dashed line. If the inequality sign does not have an equal sign, then if it does have an equal sign, then draw the line as a solid line. And third step is to shade the region that satisfies the inequality. You should get a solution at this step. If not, you have to repeat the steps 1 to 3 for each inequality. Then, as a final step, the solution set will be overlapped region of the inequalities. For example, if you are having two inequalities and you have graphed it, and the region where both the graphs intersect, that is called the solution set. These are the 5 steps that we follow while graphing the system of linear inequalities. So it may look somewhat dry when you just look at the steps. If you look at the example step by step, then you can understand the entire concept. It is very simple. I have taken an example. Determine the solution to the following system of inequalities. We have two inequalities. 5x minus 2y less than equal to 10 and 3x plus 2y greater than 6. Okay, let us follow step 1. Step 1 is to solve for y, or you have to isolate y on one side of the inequality and shift all the other terms to the other side of the inequality. Here is the first inequality. I'm just going to shift x term to the right side by subtracting 5x from both the sides of the inequality. I want to get rid of this negative 2, so I'm going to divide the entire inequality throughout by negative 2. Please notice that in case if you're going to divide the entire inequality by a negative number, or if you want to multiply the entire inequality by a negative number, this sign changes to its opposite. In case if you have less than or equal to, it will change into greater than or equal to. If you have greater than or equal to, then it will change into less than or equal to. When dividing by a negative number, please remember to switch the inequality sign. We have rewritten the inequality in terms of y. Now you have to graph the boundary line for the inequality. Please notice that in this inequality we have equal to, not greater than equal to sign. So it should be a solid line when graphing. This graph is not up to the scale. This is just a rough graph. You'll get a graph line like this. It will touch the x-axis at 2 and y-axis at 5. Since the inequality contains an equal sign, the boundary line will be a solid line. Please remember this. Now third step, you have to shade the region that satisfies the inequality. This inequality states that y must be greater than or equal to 5 over 2x minus 5. So the region to be shaded will be that above the boundary line. Greater than or equal to means shade above the line. Hope you're clear with first inequality. This is how we graph the inequality. In our question, we have one more inequality. So, step 4 should be solve the second inequality for y. Our second inequality is 3x plus 2y greater than 6. Subtracting 3x from both these sides, we get, dividing the entire inequality throughout by 2, we will get, yes, we have solved the second inequality for y. Now similar to the first inequality, we are going to graph the boundary line for the second inequality. Please notice that the inequality does not contain an equal sign. The boundary line will be a dashed line or broken line. So let me use the same graph and I am going to graph the second inequality. I have just changed the color for this graph. Now we have to shade the region that satisfies the second inequality. Please notice that the inequality states that y must be greater than or equal to negative 3 over 2x plus 3. Am I right? Okay. So the region to be shaded will be the above the boundary line. Greater the symbol, so above the boundary line. Can you follow so far? This region is the second one. Now we have to find the solution set. Solution set for the inequality will be nothing but the overlapped region. The solution set region, see here, that would include the part of the solid boundary line that is above the dashed boundary line, but not the dashed boundary line itself. So I'll just highlight the intersection, overlapped region. So this is the overlapping region. Please do not include this line but consider this line. This line should also be included in the overlapping area, the solution set. Hope you're clear with this example. Please notice how we use the solid and dotted boundary lines based on the inequality symbol. And you will also use a test point and shade the half plane that contains all the solution. To make more sense, let me take one more example and explain you. Here is the second example. Graph the system of inequalities and identify the three solutions. So as discussed in the previous problem, we are going to graph the first inequality. This inequalities, both the inequalities are already solved. Only y is isolated on the one side of the equation, inequality. So you need not solve for it. You can directly graph the inequality. So this symbol, you have to look at the symbol given in between. There is no equal to sign below this one. So you have to draw with a broken line or dashed line. So the graph would look like, even the second inequality is solved for y. So you can directly graph both the inequalities on the same graph. For the first graph, you have to use dashed lines. And for the second graph, you have to use solid line. For the first graph, you have to shade the above region, and for the second graph, you have to shade the below region. Okay, because it depends upon the symbol given in your question. The green one is for the first inequality. Let me graph the second inequality too. Less than or equal to. So I'm going to shade the below region. As we all know, the region that are overlapped is called the solution set. So you have to include this region only, and also you should include this line, but don't include the line that is broken. Now I'm going to pick 3 points in the shaded region, I mean the overlapped region, and check whether it is true or not. You must check both inequalities with your solution. I'm going to pick 3, 3, 7, 3 and negative 4, 4, negative 3. Okay. You can pick any pair of points from the overlapping region. I have picked these three. So let me check. So how will you check that? You have to take this point and consider the two inequalities given in your question. You have to plug in. This is the x value and this is y value. Replace x by 3 and y by 3 in your inequality and check whether the inequality holds true or not. This is the first point I chose, and these are the two inequalities. Now let me replace x by 3 and y by 3 in the first inequality. On the right side, I'll get negative 6, negative 5, which is negative 11. Which is true. 3 is obviously greater than negative 11, right? Now let us check with the second one. Replace y by 3 and x by 3. 3 gets cancelled out and 2 plus 1 is 3. 3 is less than or equal to 3. Yes, they are equal. It holds true. Now let me check the second point, 7, 3 in both the equations and check. Let me check the first inequality. Negative 2 times 7, negative 5, which is negative 19, right? So 3 is obviously greater than negative 19. And with the second equality, if I replace x by 7 here, 14 over 3 plus 1, which is nothing but 5.67. And if I replace y by 3, I'll get 3 less than or equal to 5.67. And yes, it's true. So let us check the third point, 4, negative 3 in the same inequalities. Replace y by negative 3 and x by 4. So I'll get negative 13 on the right side. Negative 3 is greater than negative 13. Yes, it's true. And for the second inequality, replace y by negative 3 and x by 4. So I'll get 8 over 3 plus 1, which is nothing but 3.67. Yes, it is lesser than. All the 3 points we chose are satisfying both the inequalities. So our answer is also true. You should pick any point. If this condition is not satisfied, it means you have made some mistake in the graphing part. So it is always advisable to check the points. You can pick any point on the overlap region and check whether it solves the inequality or not. Only then you can confirm whether your overlap region is correct or not. So this is how we graph the system of inequalities. Hope you're clear with all the steps. So a small quick recap on the steps for graphing the system of inequalities. You have to graph the boundary line for the first inequality, and you have to use a test point to determine which half plane to shade, or you can just look at the symbol and shade the region, and analyze your system of inequalities and determine which area is shaded by both inequalities. Please look at the symbol given. If there is a equal to sign, you have to use a solid line. If there is no equal to sign, you have to use the broken or dashed line. So if it is greater than, you have to shade the above region. Less than means below region. The overlap region is considered as the solution set. You may also get horizontal line or a vertical line also. Please look at this question. There is no x term in the first inequality. Am I right? This looks somewhat different because there is no x term. This type of equation will always produce a horizontal line. Okay. And please look at the second inequality. There is no y term here, so this type of equation will always produce a vertical line. Does this make sense to you? Hope you can deal with any type of inequality now. Okay. In case if you get any query regarding this topic, kindly